this video, I'll solve GATE Physics 2010 question 47. A particle of mass m is confined in an infinite potential well Vx given as 0 for x lies between 0 to L and infinity otherwise. It is subjected to a perturbing potential Vpx equal to V0 sine 2 pi x by L within the well. Let E1 and E2 be the corrections to the ground state energy in the first and second order in V0 respectively. Which of the following are true? So this is a time independent perturbation theory problem. So let's solve this. The perturbation is given by this potential Vpx. This is Vx L. The unperturbed potential is a 1D infinite potential well, as you can see. Otherwise, and the perturbation is given as V0 sine 2 pi x by L. So we need to calculate the first order and second order correction to the ground state energy. So the first order correction to the ground state energy is psi naught Vpx psi naught. So we need to calculate this. Now for the infinite potential well, the ground state wave function is root over of 2 by L sine pi x by L, right? So in our case this will be, and the integration will go from 0 to L sine square pi x by L, and Vpx is V0 sine 2 pi x by L and dx. So we'll have to calculate this value. Now V0 by L is out, and 2 sine square pi x by L will be minus 1 minus cos 2 pi x by L into sine 2 pi x by L dx, integration from 0 to L. So it is V0 by L sine 2 pi x by L dx minus half, this will give us sine 4 pi x by L, because 2 sine A cos B equal to sine 2 sine A sine cos A equal to sine 2A dx, integration 0 to L 0 to L. This will give us V0 by L by 2 pi minus L by 2 pi cos 2 pi x by L, limit from 0 to L, plus L by 8 pi cos 4 pi x by L, limit 0 to L. This is just the integration. So if we put the limit, so you can see this is minus L by 2 pi and cos 2 pi minus cos 0. Similarly here we will get cos 4 pi minus cos 0. Now cos 2 pi and cos 4 pi all are equal. This is 0, this is also 0, so the total value is 0. So the first order, there is no first order correction for this perturbating potential. So let's go to the second order correction to the energy, and the formula is m not equal to 1 psi m0 Vp psi 10 modulus square divided by U10 minus EM0. Here E10 is the ground state energy. Since n starts with A1 for 1D infinite potential well, so that's why we have written U10. Now we know the eigen energies for the infinite potential well is given by n square pi square h cut square by 2m s square. Now the numerator is always positive because it is a square value, so this is always positive, but the denominator is negative because U10 is always less than EM0 for m greater than 1, so the total value, the whole value will be negative. So the correct option will be the first order correction is 0 and the second order correction is less than 0. So option A is correct for this option A. So you need to calculate both of the correction and then you can see that option A is correct.